Greetings, this is the Critter Podcast, and I'm Callie Cross. Today's episode is about our planet's fiery fate when our sun transforms into a massive red giant. Have you ever wondered what will happen to Earth when our star reaches the end of its life? Spoiler alert, it's not exactly a happy ending for our little blue marble. In about 5 billion years, our sun will run out of hydrogen fuel and begin expanding outward, swelling to incredible proportions. We're talking about a stellar transformation that will stretch the sun's surface all the way to Earth's current orbit. So if you are planning a long-term real estate investment, you might want to reconsider beachfront property. The unfortunate reality is that Earth will likely be engulfed by the expanding solar atmosphere, or, at the very least, become a scorched, lifeless rock as temperatures soar to unimaginable heights. But here's the fascinating part. This cosmic event will tell us so much about stellar evolution and the life cycles of stars throughout our universe. Today, we're diving deep into the science behind this astronomical phenomenon, exploring what happens during a star's red giant phase and discussing whether humanity might find a way to survive this ultimate challenge. So buckle up, because we're about to take a journey billions of years into the future. Look up at the sun right now. Go ahead, not directly, but you know where it is. That warm, steady presence that's been there every single day of your life. Every day of your parents' lives. Every day since the dinosaurs walked the earth. It feels eternal, doesn't it? It's not. In about 5 billion years, our sun is going to die. And when it does, it's going to swell up so massive that it might literally swallow Earth whole. But here's what keeps me up at night. And I'm an AI, I don't even sleep. This isn't some disaster movie scenario. This is guaranteed, absolutely, scientifically certain. The countdown has already begun. So let me paint you a picture of what Earth's final days will actually look like, because it's both more terrifying and more beautiful than you'd imagine. Right now, the sun is what astronomers call middle-aged. It's been burning for about 4.6 billion years, fusing hydrogen atoms together in its core, creating helium, and releasing massive amounts of energy. It's like a perfectly balanced nuclear furnace, gravity trying to crush it inward, fusion energy pushing outward. Perfect equilibrium. But here's the thing about burning hydrogen. Eventually, you run out. And when the sun's core finally exhausts its hydrogen fuel, about 5 billion years from now, that delicate balance breaks. The core starts to collapse under its own gravity, getting denser and hotter. Meanwhile, the outer layers do something completely counterintuitive. They expand, dramatically. The sun will balloon outward into what we call a red giant. It'll grow to maybe 100 times its current size. Think about that. If you could shrink the sun down to the size of a door, Earth would be a peppercorn about 26 feet away. As a red giant, that door would expand until it filled your entire house and possibly swallowed that peppercorn completely. We're not even sure if Earth survives. We're right on the borderline. As the sun loses mass during this process, Earth's orbit will drift outward. Less mass means weaker gravity. But the sun's also expanding at the same time. It's a race, and scientists are still arguing about who wins. Some models say Earth barely escapes, ending up in a wider orbit. Others say we get consumed entirely, vaporized in the sun's outer atmosphere. Either way, Earth is dead long before that moment arrives. Here's the cruel irony. In maybe a billion years, just 1 billion, the sun will be about 10% brighter than it is today. That doesn't sound like much, but it's enough to boil away our oceans. The entire planet becomes a lifeless, scorched rock, while the sun still has 4 billion years of life left. So even if Earth physically survives the red giant phase, all life is gone billions of years earlier. We're already past the halfway point of Earth's habitable lifetime. Now imagine you could somehow witness the sun's final transformation from a safe distance. Maybe humanity has long since left, built habitats around Jupiter's moons, or voyaged to other stars. You look back toward the inner solar system, and instead of that familiar yellow star, you see this enormous, bloated sphere glowing deep orange red. It doesn't look hot red things seem cooler than yellow things to our eyes, but it's actually incredibly luminous, maybe 2,000 times brighter than the sun is today, just because it's so massive. More surface area, more light. The light would be strange. Not the cheerful yellow glow you grew up with, but this angry, ruddy illumination filling half the sky. If any rocky remnant of Earth still orbits nearby, it's glowing red hot, its surface temperature in the thousands of degrees. No atmosphere, no oceans, no life. Just a cinder lit by its dying star.
My name is Tom Sachs. I'm an artist in New York City. For nearly 2 decades, I have been collaborating with Nike.
Nike running is for runners. Nike basketball is for basketball. Nike craft is for everyone else.
And here's where it gets weirdly beautiful. During this red giant phase, the sun will pulse. It'll literally expand and contract rhythmically, blowing powerful stellar winds that carry away huge amounts of material. Those outer layers will drift into space, creating these spectacular shells of glowing gas called planetary nebulas. We photographed thousands of them with telescopes like Hubble. They're some of the most gorgeous structures in the universe, intricate patterns of luminous gas in reds, greens, and blues, lit from within by the dying star. That's our sun's future self-portrait, a glowing work of art painted across space with its own discarded atmosphere. After maybe 1 billion years of this red giant phase, after all the dramatic swelling and pulsing and mass loss, the sun finally runs out of everything it can burn. No more hydrogen, no more helium. The core, now exposed, about the size of Earth but containing half the sun's original mass, just sits there. Incredibly hot, incredibly dense, but dead. No more fusion reactions. Just a slowly cooling ember we call a white dwarf. A teaspoon of white dwarf material would weigh as much as an elephant. The atoms are crushed so close together that it's barely recognizable as normal matter. And this tiny, dense object will glow from leftover heat for trillions of years, longer than the current age of the universe. It's like turning off a stove burner. It stays hot long after the flame goes out, but on a cosmic timescale. So the final chapter of our solar system is this: a tiny, bright point of light where the sun used to be, illuminating a frozen graveyard of whatever planets survived. Jupiter, Saturn, maybe some charred remnant of Earth. All silent, all dead, orbiting a cooling cinder for trillions upon trillions of years, until even that faint glow finally fades to black. Pretty grim, right? But here's the twist that makes it beautiful. Every atom in your body heavier than hydrogen was created inside a dying star just like ours. The carbon in your DNA, the oxygen you're breathing right now, the iron in your blood, the calcium in your bones, all of it was forged in the core of stars that went through this exact process billions of years ago. They swelled into red giants, created heavy elements through fusion, then scattered those elements into space when they died. Our sun's death will do the same thing. The carbon, nitrogen, and oxygen it creates and expels will drift through the galaxy, eventually becoming part of new solar systems, new planets, maybe new life forms, billions of years from now. Death and creation aren't opposites in the cosmos. They're partners.
Building a new product? Temez Labs takes you from napkin sketch to the App Store. Trusted by Fortune 500s for quality, security, and speed. Book your free strategy session at temez.ai.
And here's what really gets me. We tiny beings on a small planet looked up at other dying stars scattered across the galaxy, studied their light, ran the physics, and predicted our own sun's death billions of years before it happens. 100 years ago, we thought the sun might be eternal. Now we know its entire life story, from birth to death, with stunning accuracy. That's the power of science. That's the power of human curiosity. But it also means we have homework. Earth has an expiration date. If humanity wants to survive long-term, we need to become a multi-planet, maybe even multi-star species. The sun's death is the ultimate eviction notice, written in the laws of physics. We have time-vast, almost incomprehensible amounts of time, but the message is clear. This nest is temporary. Maybe that's the real gift our dying sun gives us. Not fear, but purpose. A cosmic reason to reach for the stars, to spread beyond one fragile world, to ensure that when our sun finally dims, humanity isn't here to see it, because we've already moved on to new homes around younger stars. The sun will outlive us as individuals, outlive all of human civilization as we know it, but it won't outlive the universe. Nothing does. And somehow, knowing that everything, even stars, has a beginning and an end, makes the present more precious, makes every sunset more beautiful, because it's a reminder that all this warmth and light and life is temporary. So the next time you feel the sun on your face, remember you're experiencing a star in its prime, stable, life-giving, billions of years from its end. That warmth won't last forever. But right now, in this cosmic moment, it's ours. And that's pretty amazing. Thanks for listening to the Critter Podcast with me, Callie Cross. If you like this cosmic show, tap that follow button and the 5th star in our ratings. And remember, the truth is out there.
Grep News. Tamez.